So today we'll talk about the Unix shell. And I got a lot of questions about I commands and iRods. And so I just want to kind of talk about a little bit of why we're learning the shell. So we're learning the Unix shell because it's one of the most, despite it being developed in the 1960s and 70s, it's still one of the most in use text interfaces with computers. And you'll start to see that there's a lot of similarities between the commands that we're going to learn today and the ones that iRods uses. So once you start to learn what we can do with the Unix shell, you'll start to see the orthogonality between, or the similarity between iRods and Unix commands. So hopefully that makes a little more sense. I got quite a few questions about that in the surveys and via email. So we'll also revisit the iRods for iCommands for exporting the R outputs into your own directories on the data store. So we'll kind of try and tie everything all together. And if you would like, I'll post a poll in Zoom. And now I just want you to say yes or no if you've used the shell to do anything before. Okay, well, thanks for the quick response, everybody. That was less than a minute of having the poll open, and pretty much everybody responded. So it looks like about 80% of you have never used the shell before, so that's great. We're going to go through that today. So the first thing we're going to do is launch our CyVerse containers. And so I will share my screen. So I have a running analysis, but I'll just walk everybody through this one more time. So what we're going to do is go to our apps in the discovery environment. So, and then this AG2PI community. And we're going to be using this Rocker RStudio verse right here. And then the quick launch. And this is what we went over on Tuesday as well. And then we're going to use it. So give me a raise your hand in Zoom if you have not gotten to this point yet. And I will pause here for a moment. So that's a great question, Miranda. We did some behind the scenes work with, no, Tyson, you cannot use it.
Okay, I forgot you redid it.
Yeah, so we changed a lot on in the back end behind the scenes to make this a little bit easier. So you can cancel it and relaunch the same application, and then it should be fine. But we changed a good deal on like the server side yesterday, as well as a few of the inputs. So that's a good question, Christine. So what is meant by the shell? So the shell will make a lot more sense when we're in the environment, but it's essentially a text prompt where we can do things without using the mouse and interact with the computer.
Hey, Ryan, do you mind if I just jump in a little bit on that?
Yeah.
So for those that aren't familiar with what the shell is, when it came to early computers, before we had these nice graphical user interfaces, everything was done just by typing on the command line. And so when you, the original operating systems would create this environment that would have a bunch of these commands built in that would let you do stuff on the computer. So before we could like right click and say make new folder, what we'd have to do is say make directory. And the shell is the environment that lets you type in those commands. So you can think of it very similar to what you see now on a modern operating system with this graphical user interface, what we call the GUI based way to interact with your computer, before GUIs existed, where everything was just typed in there. And when it comes to shells, there are a bunch of different ones that you can use, just like you could use a Mac Windows system, a Windows system. Whoa, that's a hard one. And so on and so forth. So when we talk about the shell, it's just that generic command line interface, often into a Unix or Linux-based environment. I hope that was clear. But if you do have any more questions on that, I would be happy to talk to you more about it, either through chat or we can set up some time over one of the breaks.
Okay, keep your hand raised if you're not at the launching the app. If you're at this part, please lower your hand in Zoom. Okay, so now we're going to select the input folder so we can browse the data store. And so you'll find this in the community data folder. And so if we go down in the community data folder, there will be this AG2PI workshop. We'll just select that and hit OK, and then launch the analysis. So then you should see this screen right here. And then this will go all the way through. And eventually it will say that it's loading the app itself. This will change from pending to, I think, staging or loading the app. And then we'll get RStudio. Yours will probably look a little bit different since mine is zoomed in, so it's a little bit easier for you to see what I'm typing. So raise your hand if you didn't get to this step right here, and you need a little help from one of our helpers.
Hey all, I'm gonna create a breakout room. I'm gonna go hop into breakout room 1 for anyone that's having trouble. If you wanna go join me there, then I can take your questions a little more easily.
So to answer your question about the load time, it depends. So since we are all launching these at the same time, it can be a little bit slower to load. When there's more, I would say, normal traffic of people starting and stopping jobs, it starts a little quicker. So if you're still having trouble getting on to the app that's not stuck in the pod phase pending, Eric is in breakout room 1, if you'd like to join him. So let's see. Okay, so I think everybody is getting help that needs it to get to this point. So just give me a thumbs up if you have RStudio open, and then we can start sort of getting into the terminal or shell and go through a little bit of the basics. Cool. Seeing some thumbs up. Okay, so when you're in RStudio, it won't look nearly this zoomed in, but you'll have this environment pane over here, and then the files and plots pane in the lower right-hand corner, and then you'll see this console. So the console is actually for the R programming language itself. It looks very similar to the shell, but this is a very like R specific thing. So if we click on the terminal right here, in between the console and jobs, this will take us to the bash shell inside of RStudio. So Eric did a really good job at introducing what the shell is. And this is particularly what, if you have access to like a remote server, like at your university or your government institution, this might be what you're presented with rather than a graphical user interface like Windows or Mac OS or Linux. So this is where everything sort of starts once you get outside of the graphical user interface. You'll start here at the command prompt, which is usually indicated by some sort of symbol and then a blinking cursor. In this case, it's a $sign or sigil. And so if you follow along in the introducing the shell on the read the docs page, there we'll be using the $sign to indicate the shell terminal and where, like, what commands should come after it throughout the entire lesson. So we're going to try our first command. We're going to try the command ls, which stands for list or listing, and this will list all of the contents in the current directory. So if we type ls into the terminal, we'll see that there are two things inside of this current directory. That would be this thing called input and this thing called kitematic. If you end up making a typo, like for example, you type in ks instead of ls, bash will tell you that the command is not found. But otherwise, you should see input and kitematic. give me a thumbs up if you're able to get your RStudio open, get to the terminal, and run ls for the first time today. Okay, so I hope everybody was able to get to this point who's getting help in the breakout rooms. So go over the command one more time. So this is the list command, or ls, listing. So we're going to list the contents in our working directory. So I mentioned working directories. So what is the working directory? So the working directory is the folder that you are currently in the shell. And we can find out what our working directory is by typing pwd, which stands for print working directory. So this will tell us where we are in the file system. So there's an example file system on the Read the Docs page that I'll just drag over really quickly. So the file system, so we see this first slash. So this is the root. That would be right here in the file system if we were to draw out a diagram. And then we have, instead of users, so this is just an example file system. This isn't the one that we have. So then there's this users, which in this case is home. And then inside of there, instead of having Imhotep, Larry, and Nelly, we have our user, which is RStudio. So this is kind of where everything starts when we fire up an instance of the shell. So the first slash is called the root directory. So that is where everything starts in the computer and sort of builds off of that. In the example, there was the bin directory and the data and users and temp. So there'll be all of these different files in the root, or folders rather, or directories in the root that have some function for how the computer system is working. So within our current working directory, RStudio, we see that there's this /home, and then we see that RStudio comes after that home. So home is inside of the root directory, and then RStudio is inside of home. So this slash has a little bit of a dual meaning, this /. So if we type ls again and do dash and then an uppercase F, so this is important to use the uppercase. we can see now with that option, which is also known as a switch or a flag, it tells us that we want the computer to list and classify everything. So this is going to add the / to the end of input and kitematic because they're both directories. So the trailing / is going to indicate a directory. The @ symbol would indicate something that is linked on the computer. And if it was a program that we could run, there would be a star after it, indicating that it is an executable. So with different kinds of shells, they might be color coordinated or color coded to show you the difference between files and folders and things you have access to and things you don't have access to. So let's clear the terminal with the clear command. So this will clear the terminal and start us over with the prompt at the beginning. And let's go over some of the general syntax of what a command would be in the shell. So we have, let's try it with the ls with the uppercase F flag again. So we'll do this ls dash uppercase F with the /. And this will tell us all of the folders inside the root directory. Because we told ls that through this /, which we would call an argument, that is where we want the list command to look. So we can see that there's this executable init, and all of these different templates and folders. So this is a little bit of a glimpse into like the root directory above. So if we tried running ls without the space, we get the command not found. So with the flags, it's important to leave that space in there. Otherwise, the bash shell is going to interpret the entire command as ls-f, which doesn't exist, rather than ls with the flag uppercase F, which does actually work. And so the capitalization, as I mentioned, is also pretty important. So we can try a different flag called S. So this will display the size of the files and directories. So this will say total 0. So if we change this to say input / AG2PI _ workshop /data, we'll get a different result. So this tells us the size, the number of files and directories alongside the names. And then if we look at this again, but with the capital S, it's now not telling us the total, but rather sorting the list by the size of everything in the directory. Okay, so let's clear the terminal again. And let's ask the shell, or the bash shell, as I mentioned. Thanks for pointing that out, Meg. That bash shell and the shell are all interchangeable, all interoperable with each other. So if we're curious about how a command works, there's two different ways that we can ask our command line for help. So it's the help flag with the double dash. So it's dash dash help. And it'll list out a lot of text. So ls has a lot of different options for it. And if I'm being totally honest, I have not personally explored every option. So that's one thing that we will sort of realize, is that since this has been around for so long, there are so many features that are packed inside of some of these functions that we're just learning at the beginning, these different tools inside of the shell. So this is a good way if you're trying to figure out, how do I list for a specific thing, or how do I list in a particular way that also excludes certain files or folders. So you can ask for help, and then it'll print out all of the different flags that you could possibly use with ls. Another way that we can ask the shell for help is by typing man, M-A-N, which is short for manual, and then ls. And it says command not found. So this is a very workspace dependent command. So certain operating systems, so the operating system that is running RStudio behind the scenes inside of the discovery environment, does not have the manual function installed, but it does work on Mac OS. And if the man function doesn't work, the dash dash help function should work. So if you try one and it doesn't work, then you can try the other approach. And you should be able to figure out what the different help options, or display the different options for the flag. So if we try to run ls with -j, or the flag j, let's see what happens. So it'll say ls invalid option j, try ls -- help for more information. So if you input a flag to a command that doesn't exist, it'll also point you in the right direction to ask for help. There's also the Unix manual page on the web. It's very dense. It's often easier to ask the command line what you need to know, but we'll also go over some other places where we can get help tomorrow when we're wrapping up. And so let's just do a little exercise where we put the answer in the chat. So using help, I want you to post in the chat, what does the command ls do when used with the -l flag? What happens then when you combine -l, lowercase l, and the lowercase -h option? So this is also, if you don't feel like posting it in the chat and you just want to think about this, work through it, this is also on the read the docs. So there is, throughout this lesson, there are different questions, which may be programming related, or just like this, a question to get just to get you to think about what we've done so far. And then you can click on this little arrow and it will reveal the solution. Likewise, there is a listing in reverse chronological order question, which has a solution as well. So I'll pause here and let people start to catch up. And some people were having some issues getting on CyVerse. So I'll pause here and I can take some questions related to what we've covered so far in the chat, or feel free to unmute yourself and we can discuss what we've talked about so far. So the videos, Cora asked where the videos from the workshop will be posted. So they're going on the AG2PI organization website. And then when this is all done, I will try and put links to those videos on the Read the Docs page. So you can go back and follow through this a couple of times to practice afterwards. It's a great question. Yeah, so that's the answer, Miranda. And so if we do ls-l, we get the long listing format, which tells us more information about like the read-write privileges, when the folders were created, when, and so we can also run that on the input AG2PI _ workshop. Oops. And it will list out all of the contents of that directory. So this is going to look different than just listing the contents. It's going to give us a lot more information. As you see, the regular ls will just output everything and fill the screen and then start on a new line. This will go line by line in alphabetical order of everything that appears in the folder, alphanumeric order. And so you can try this and see what it looks like with the -h flag. And now what does the -h option do? So the -h option is taking the file sizes and making them human readable. So the -h in this case is making everything human readable. So you can see like with this PDF file, solar.pdf, it says 22K rather than when we don't use that flag, it lists it out in the exact number of bytes. So this just makes it a little bit easier for us to read our file sizes. Okay, so there's another exercise in here that says listing in reverse chronological order. Feel free to go over that in your own time. I'm gonna, for the sake of time, I'm going to move on to exploring other directories, and we'll go through that, and then hopefully we'll get to the break after that. At 10. So we can use the ls. So I've already kind of demonstrated this. Let me clear my terminal. I've already demonstrated this without explicitly saying it, that we can look at the contents of other folders without that being our working directory. So if we use the ls-uppercase F input on the AG2PI underscore workshop, we can see that there are these different folders and files inside of our input folder that we selected from the data store. And so you should see these when you run this on the input/AG2PI workshop, directory in the command line. And so this will list all the files and subdirectories in there. And this is kind of like if you were to use the Windows Explorer, so I got a question about if you cannot access it, we'll be able to see if you have the folder in a second. And if you can't access the input AG2PI workshop, we'll see if somebody can help you at the break. That probably means that it wasn't loaded in the app when it was launched. So we can also, knowing that there's this other directory input and this AG2PI workshop directory inside of that, we can actually change our working directory and go there with the cd command. So cd stands for change directory, and we can type in input /AG2PI workshop. And then you'll see that this changed. So this is the shell telling us what directory we were in. So before we were in our home directory, and now we're in the AG2PI workshop directory. And so we can check that with ls. Now we see everything that we saw when we used the ls-f flag. If we type in cd again, without any inputs, it will take us back to our home directory, which we can view with the print working directory. And if we wanted to go individually up the file system, we can do individual change directory commands, like change directory input. And then we see right here, this is changed to input. And we can list. And we see that there's another, if we do ls, the uppercase F, we can see that there is another folder called AG2PI workshop, which we can change into that. And then we can list the contents of that. And then we see that there's a folder called data. And we can decide now that we would like to go even further up the file hierarchy into the folder data. So now if we do the print working directory, it will give us our full path with the root and then the home, our studio, input, AG2PI _ workshop, and then data. And we can see all of the contents of the data folder with the ls-uppercase F. So this is going to be these print working directory, ls, and change directory or cd are the commands that I use most frequently in the command line to move around on file systems, to see where I am, to see what files I have. So these are probably the 3 most important commands. And so let's say we wanted to go back to the AG2PI workshop. Let's try that. Go back to that directory. I get no such file or directory when I put that folder name in. So why is that? So that is because change directory only looks 1 layer up in the file hierarchy. So if we look at our working directory, it's looking inside of the data folder itself for a folder called AG2PI _ workshop. So if we wanted to go back 1 folder level or 1 directory level, you can do that by just typing cd and then 2 periods or dots. cd ... and that will take us back 1 level. So it'll take us back to AG2PI workshop. We can check that by typing print working directory or pwd. And we can list the contents of the folder, and we see the data folder again. And so sometimes we need to list all of the files in a folder. Sometimes files and folders can be hidden. So we can do that with the -a flag. So if we run ls-uppercase F-A, we'll see that we get a few other directories that don't really have names. They're just dots. And so if a folders begin with a single dot, such as the ones that we see here, or files begin with that, that could mean that the files or folders are hidden. But in this case, this is the current working directory. So that's the special current working directory. And then this is indicating the next folder, like that this was contained in. So this would be input. So this is why the change directory with the 2 periods allows us to go backwards. And there's some documentation in the read the docs about other files and folders that you might encounter that are hidden. And so I will leave you to read that on your own. And so I'm going to go over some shortcuts for getting around when navigating directories. So we see this tilde right here, which is the squiggly line and the /. That, if we change all the way back to our home directory, is representative of our home directory when we log in. So if we print this, pwd home RStudio, we can abbreviate that whole home/RStudio with this tilde. And another neat trick, which is fantastic when we have long names, is I can start typing in and then hit the tab key, and the shell will automatically complete the folder name. Since I was looking for input, I typed IN, it automatically completed that. So let's try it with a letter that's not one of the folders inside of our home directory. So if you keep hitting the tab key, nothing happens. It won't automatically fill it in. So this is really great when you're working with folders that have really long names and you're trying to make sure that you don't make a typo. I didn't know about tab complete for a long time of working in the shell, and I would meticulously type everything out until one of the programmers that I was collaborating with showed me tab complete, and it made my life so much easier. So we can tab complete this, and then if we want to change to AG2PI workshop, we can type in AG and then hit tab, and it will automatically complete it. Yes, I see a lot of love for tab complete in the chat. It is the best. Like this is what makes, I think, one of the things that makes the shell easier to use more than anything else. Tab complete will help you with any command. It doesn't have to be ls or cd or anything like that. Like you can tab complete any file or directory when you're writing any commands in here. And it's just going to be so much easier to do. So I showed you all the tilde. So what that actually is a relative path. So if I type in print working directory here, it's going to give me the full path. This is going to be the absolute path. So this is saying inside the root, there's a directory called home. Inside of the directory home, there's a directory called RStudio, which happens to be our username. And then inside of RStudio, there's a directory called input. And inside of that directory, there is a directory called AG2PI workshop. And since we typed in print working directory, that is where we currently are. So if we were to type in something like change directory tilde input, that will take us back to the input directory, and we used a relative path to get there. So the relative path is very handy when you are moving around on a larger file system and you want to go to a directory without, go backwards in directories. So I'll give an example. So let's say we want to go to the AG2PI workshop, and we want to go to the data folder. and then we print our working directory. So say, oh, that's a really long path to get back to the directory input, right? Like if you wanted to go backwards by using the ... it's only going to take you back to the AG2PI workshop. So we can go and do this and say, take us back to input, and we print our working directory. We're back in the input directory. And now if we want to change back to the data folder, we can just do cd ag tab complete, hit D, tab complete to data, and go back there. Now we can do another way to get back to our input directory, since we can see the folder hierarchy right here. We can go cd and then ... So that's going one folder up, and we can type a / and say we want to go to the level below that. So this is now telling it change to the folder just below this one, which would be AG2PI. And then the / is saying, and then the folder or directory below that. And now we're back in the input directory. So that is what we would describe as an orthogonal command. So we're doing the same thing in multiple ways. And this is something that the shell is pretty much, there are so many different ways to do the same thing and get to the same point. I think it's whatever you can remember or sits well in your mind for moving around is probably the easiest to go with. And then over time, you'll start developing a little bit of muscle memory of these different commands. And then you'll be able to easily navigate around from different folders through different file hierarchies. And we've come to our first break today. So I will clear my terminal and I will pause the recording and stop my screen share. And then Meg will talk about, now that we know how to move around in file or in directories, Meg will talk after the break about what working with files and directories is like in the shell.
Hopefully most people are back. You want to give me a thumbs up if you're back and ready to get started? See 1, 2, 3. Okay, yay, everyone's back. Awesome. Okay, so I'm Meg. I'm taking over for a little while to walk you through a little bit more of these lessons. I do want to say we're skipping a lot of the exercises just so we can try to get through some more material, but I'd really encourage you to go back and do them on your own. Like go back through this one more time and do the exercises and look at the solutions and make sure they make sense. I teach this to biology students every fall at the University of Tennessee, and nailing relative paths and absolute paths is definitely the hardest part. If you can get over that, if you can navigate the file system, then I can teach you almost anything on the shell. But that's like the key thing that takes a good bit of practice. So definitely consider going back and doing those exercises. Also, you can always use CyVerse and you can use this RStudio terminal. But you can also do this on your own computer. So if you have a Mac, it comes with a terminal program. And if you have Windows, it comes with PowerShell, or you can download a terminal program. So you can always practice on your own computer too, which is really good. Okay, so let's start by making sure that we are all in the same place. Hopefully, I think we all left off. Get all my windows arranged here. If you're looking at your terminal in RStudio, it's very conveniently telling me the path on the prompt, which is awesome. I think that that's probably the case for everybody, but if you're ever on a shell that doesn't do that, of course, we can always do pwd, but I absolutely love that and you can actually change this on, if you log into another computer and it doesn't show you the path, that's something you can Google how to change. So that's super convenient. So hopefully yours says tilde/input/AG2PI workshop. Now, what if you're somewhere else? Well, that's no big deal because we've learned how to change directories. So you could just cd to tilde/input/AG2PI workshop. And with tab complete, you could do cd tilde in tab ag tab and do that in about a quarter of the time, which is why tab complete is the best. From here, let's check out what kind of folders and files we have. So it looks like we've got about 6 folders, and I know they're folders because they've got those slashes after them, and a few files. So one of the things we really need to be able to do, not just navigate, but to maybe create some file structure. So let's start thinking about creating a directory. The shorthand for that is mkdir, M-K-D-I-R. I remember when I was a computer science student, I had a piece of paper taped on the wall next to my desk. And as I learned commands, I would write them on that piece of paper. So that still may be something that will serve you well, because a lot of the things we're learning, ls, cd, mkdir, they're like close enough to be kind of memorable, but they're missing some letters. And it's hard to remember which letters are missing. Eventually it'll just become second nature. But in the meantime, a little cheat sheet on the side can be helpful. So to create a directory, we need to give it a name. We need to give this new directory a name. So let's say we are going to make a directory called thesis, just like that. And now if we do ls-f, we'll see that we have a brand new folder showing up inside of our current location named thesis. And we've just created it, so it's empty, but we can confirm that it's empty by doing ls-f thesis. So this is a relative path. We're saying relative to where I am, look in this folder that is in the directory that I am currently in. Also, there's a really nifty flag for mkdir that allows you to make a whole bunch of directories all at once. And so that flag is -p. And so maybe inside of thesis, we know we want a directory called chapter, and we know chapter 1, and we also know that we want a directory inside of that called section 1, and we want a directory inside of that called subsection 1. And so if I do that, it will actually create this whole nested directory structure for us. So, and this leads us to another really nifty flag for ls, which is R. Capital R, and capital R means recursive. And so by recursive, that means don't just look in the folders that I can see right now, look inside those folders. And if those folders have folders, look inside those and keep looking inside all of the folders until you get to the end and there are no more folders to look into. So let's see what that looks like. So I'm asking it to look inside thesis recursively. So go through all of the folders inside of thesis and show me what's in there. So it says, okay, I see thesis. Inside of thesis is chapter 1. That's a folder. Let's take a look inside of it. Inside of thesis chapter 1, section 1. That's a folder. Let's look inside of that one. And so it keeps going down, and then it finds subsection 1. And then when it looks inside of that one, it's finally empty. So this is a really quick way, if you're sitting at the top of a complicated folder structure, to see all of the folders and subfolders and files that are kind of nested below where you currently are in the file system. This is actually quite powerful if you get into very complicated sets of files and folders and you're trying to figure out where things are. Yeah, so this is very much like having a GUI, like a file explorer on your laptop. And perhaps I should show you an example of that. So this is my desktop folder. So this is something you don't have to do. You just take your hands off the keyboard and just sit back and relax for a second. This is for my laptop, my file explorer. And I have a very messy desktop, so that's embarrassing. And I work on trees, so I've got folders named like apricot and buttermilk and butternut, and there's some ash stuff in here. Great. I can open a terminal to my own computer, CD to the desktop, ls, and I can see these exact same files. There's the butternut, there's the apricot. So it's just two different ways of interacting with a computer. So this is not specific to CyVerse. This is not specific to RStudio. This is something that you can find on any Linux, Apple, or Windows machine. You can interact with your file system this way. So hopefully that helps to kind of clarify why we're learning this. And some high performance computational systems mentioned earlier, the command line may be the only way to interact with the file system. But if you visualize it in your head as though you're exploring it through the GUI, that can help you kind of figure out where you are and how to navigate. Since we're getting into creating files and folders, it's good to take a pause and talk about how to name files and folders. When you're on the command line, it turns out that it's more important how you name things. First and foremost, don't use spaces. If you try to put your laptop, assuming that it's Apple or Windows, is happy to let you use spaces in your file and folders name. If you try to do that and use those files and folders on the command line, it kind of turns into a total disaster because the command line interprets space as meaning two different things. If it sees a space in the middle of name, in between two different words, it's going to say, okay, those must be two different files. So if it's actually a file with a space in the name, it's kind of a pain to deal with. So just don't use them. That's the rule. Just don't put spaces. If you need to indicate kind of two words in a name, you can use an underscore. So like here we have AG2PI underscore workshop. That is, if you're working on the command line, a much better name than AG2PI space workshop, which would have made our lives a little miserable. So the kind of the shorthand is always underscore or a dash. However, don't begin the name with a dash. We've already seen that on the command line, on the shell, you're going to use things that begin with a dash or flags. So if you start naming things beginning with a dash, again, going to make your life a little complicated. You're going to get unexpected behavior on the command line. In general, I don't mess around with too many special characters either, because a lot of them have meaning on the command line or in programming languages. So generally, name things with letters, numbers, dashes, underscores, and periods. That's all I would recommend using. And preferably you start with a letter. Don't start with a special character. So that's a lot of rules, but in general, that just means name things pretty intuitively and just try to avoid anything too wacky. Okay. The next thing we're going to learn how to do is how to create a file. Let's CD into our thesis directory. And as a reminder, I talked a lot, so we might have forgotten what I did earlier. Chapter 1 is a folder in here, but we don't have any files. So maybe we're ready to start our draft. And so we want to create a text file. We are going to do that with a program called Nano. So you type nano draft.txt. And now I am going to hit enter. And something very crazy has happened. It's kind of like, oh, I guess we didn't really see a working, man kind of behaves like this on a shell when man works. But what it did is it took over, this Nano program took over my entire shell. I no longer have a prompt. The shell is no longer waiting on me to type in the next command. It's saying, here's a text editor. The whole shell is this text editor. And it's very much just a text editor. Nano doesn't have a lot of features. Nano is very rudimentary, but it works. There are really great command line text editors out there. I use Vim. I'm a Vim. I love it. I advocate for it. But there are people in my lab who use different things. There's also people who love Emacs. But this is a great place to start. Some of those other text editors, it's a lot to learn, that you need to do a lot of practice. It's a big learning curve. So this is a great place, and it'll definitely allow you to create files on command line. So let's just add some text here. You should have a little blinking cursor and be able to just start typing. The example is, it's not publish or perish anymore. It's share and thrive. So if you don't want to type all that, you can just type some gobbledygook. It's not going to really matter for our lesson. Just to prove to yourself you can type things. That's pretty much all we're doing here. There is something a little bit wacky about this, particularly in RStudio. So normally what we would do on a regular terminal is hit Control O. And so you have this like key down at the bottom. And this is a little shorthand telling you like, how do you get help? How do you write out? And write out is kind of a weird way to say save. It just means save my work. And the other thing we really need to know how to do is exit. We're not going to go over the rest of this stuff. As you get more into Nano, you can figure out how to use it. But just for the bare bones, you need to be able to save and exit. So normally we would save with Control O. That would normally save it to the command line, and then you could exit. Because we're in RStudio, we're getting this little pop-up. And what I want you to do is just hit cancel. This will kind of take us down a path we don't want to go down, back into the RStudio innards, and we don't want to do that. So just hit cancel, and instead just hit Control X. And you should have a little key on your keyboard called like CTRL. That's when I say control, I mean like that key. Control X. And this time it doesn't pop anything up. But since we haven't saved yet, because we hit cancel, it says, hey, you want to exit, but do you want to save your work before you exit? And so we want to answer yes. We want to say, yes, let's definitely save this work. So I'm going to hit capital Y, and then it gives me another option, which is, do you still like that draft.txt name? You opened it and you called it draft.txt. Do you want to keep that? Is that still good? And yes, indeed, that's good. So you can hit enter. And the magical Nano text editor closes and gives you back your shell. So now you're back to having your command line and your prompt, and we're back to where we were when we started. So let's prove to ourselves that it actually got created. That's important, right? So there it is, draft.txt. We can see that we opened it with Nano. We added some content and we closed it. And just to prove to ourselves that that content is still there, we can open it back up. Do Nano draft.txt. It's still there. We can still see it. And then we can Control X. And in this case, we haven't made any changes. So it's not going to ask us to save. It says, OK, great. You haven't made any changes. You're just going to exit and pop out. And I can't see the chat. So if you guys have any questions, please feel free to use the chat, and the other helpers will definitely help answer any questions. If you get stuck and you can't get Nano to go away, that I've seen that problem before. There's actually another way that we can create a file. We can do the touch command, touch myfile.txt. And in this case, it's creating a completely empty file. And we can prove to ourselves that it's empty by doing ls-l, which we learned earlier. So we can see here, we've got a little bit of content in draft.txt. We added some text, so that makes sense. But this myfile.txt that we just touched is completely empty. So at this point, you could open it up with Nano and add some information or not. However you want to create it, you can touch the file and then edit it, or you can just edit it with Nano initially and save it, and it will still exist. So you may have noticed that both of these, I named them .txt. This is good practice on any operating system, Linux, Apple, or Windows. is to give your files descriptive names, but to also give them proper extensions. And this is really important on the command line when you're trying to figure out, and especially as a scientist, this is extra important, because if you have a text file, you want to read it with an editor. If you have a FASTA file, which is generally something that holds DNA or protein sequence data, you may want to put it into a program or software program. If you have a CSV, a comma separated value file, you might want to put it into a spreadsheet or into our programming language. So all of that is just to say, when you create a file, give it a proper extension. Often if you're doing nano, you're going to want to give it the .text extension. Yeah. Okay, so we have a draft.txt. What if we decide that we don't really like that name? It's not a great name. We decide it's not really, we put some quotes in there. We didn't really put a draft of a thesis in there. So we can actually use the move command. So to back up just a little bit, move has two main uses, where you can use move to rename things, and you can actually use move to move things to new locations. And this is another one of those gotchas that I find that new people on the command line can sometimes get confused about unless it's explained really clearly. Move does two things. It's probably not great, that it's a little overloaded. It's got a little too much going on. But just to state that again, move is to rename a file. So you're going to move it from one name to another name. Move is also to take a file and move it to a new location, like a new folder. So let's see how that works. And we'll do it. Well, actually, we're going to do it with a relative path example, just to keep practicing with our paths. So I backed up one directory.
Could you please clear the terminal so that people could see it at the top? Some people in the chat mentioned it was hard to see when it was at the bottom.
Here, and I can also kind of shorten it here.
Cool, thank you.
Yeah, that should help if there's like stuff down at the bottom. Cool. Yep, so I backed up one directory. So now I'm in input AG2PI _ workshop. And if I do an ls, I can see my thesis folder that I created. And now I can change the name of that draft.txt to, let's change it to quotes.txt. So I'm going to type th and hit tab complete. And then draft dr and hit tab complete, and it'll fill in draft for you. So again, super nifty. And then th tab complete. So I want to keep it in thesis. I don't actually want to move it out of that folder. I'm going to leave it in that folder. So I'm going to give it the path to that folder and then do quotes.txt. So that has actually moved that file. It has renamed it from draft.txt to quotes.txt, but it's left it in the same location. So now if I ls thesis, I can see chapter 1, my file.txt, and quotes.txt. So draft.txt has indeed been renamed to quotes.txt. Okay, so we saw this first usage of move, which is to rename something. Now let's see the second usage, which is to move a file to a different location. So let's say I decide that I want that thesis quotes.txt to be in the current folder that I'm in. The shorthand for the current folder that I am in is a single period. So 2 periods means the directory above where I am. A single period means the directory that I am in right now. So if I do that, I will see that I now have quotes.txt in my current directory. And if I ls thesis, it is not there. It has been moved. So that's why it's called move command. It is not copying. We will learn copy next, but it is literally moving that file. And this is very much equivalent if you're used to a more graphical user interface of dragging and dropping a file into a new location on your operating system file structure. So if you drag it out of one folder and into a different folder and it moves, that's the equivalent of the move command. So here is another quick exercise that we will leave up to everybody to practice on their own. And we're just gonna pop on over to copy since I already mentioned it. Okay, so copy does exactly what you would imagine. It copies something. It can copy something to a new file in the same folder or to a file in a different folder. So unlike move, you can actually kind of do two things at once. You're copying it to a you're making a copy of the file, but at the same time, you can actually put that copy somewhere else. So let's see that. So we can copy quotes into thesis, and maybe here we'll call it quotations.text. So now, because it's copy, we still have quotes here, but we also have quotations.text in our thesis folder. So, and these two files are identical. They have identical content. And we can also, if you try to copy a directory, you have to add the -r flag for recursive. So we already saw recursive earlier, which means don't just look in this one folder. Go through all of the folders and all of the files and all of the parts underneath that folder. And so that's what we're doing with copy and -r. So it might be a really good thing to make a backup of your thesis. That would you wouldn't want to lose that. So you could say copy that -r thesis to thesis backup. And in this case, we now have thesis and thesis backup. And we can do an ls on thesis and thesis backup. So this is sort of an interesting usage of ls. We can give it two arguments and say, I want you to give me an ls of both of these folders. And ls is smart enough to know to go through each of the arguments that you give it one by one, and also to kind of annotate, hey, this is the contents of thesis, and this is the content of thesis backup, which they're identical, so we can see that our recursive copy actually worked. Always a good idea to make the backup copies of raw data and important things. Yep, and then there is another exercise here about renaming files. Again, looking at what is the difference between copy and move, and just a few little gotchas there. You would, for move, you really need to provide another name. And whereas for copy, you can just copy to a location. So let's actually do a really quick example of that. If I say copy pizza.cfg to thesis, I can do that. I don't actually have to give the copy a new name. I just now have a copy of pizza.cfg in thesis. Or I can copy it and give it a new name. So I could call it pizza2.cfg. And now I'll say ls thesis. I have pizza and pizza too. So just, I think this exercise, I just wanted to highlight that. Again, do it on your own and work through it. But I just want to highlight that there are kind of two ways to do a copy. You can copy something to a location and it will by default keep its same name. It will be two independent copies of the file. Or you can copy it to a location with a new name and it will be copied with that new name. So copy and move, they're both very powerful commands, but they take some practice because they're pretty flexible. So the flexible part is great when you're really used to the command line and it allows you to move really fast and do things really accurately and quickly. But when you're new, it's super confusing because it's so flexible. So just keep working with it and keep trying things. It's great to have these little, to be able to pop onto this CyVerse terminal and play with these files, because say you accidentally delete the whole directory, who cares? You can just create a new instance, load it back up as your input and start all over. So it's a very forgiving sandbox for you to play in here. And playing is definitely the way that you get better at the command line. Playing or just, absolutely having to get something done. And you just keep Googling until you get better at it. Okay. Let's move on to removing files and directories. Let's say I've decided that I actually don't want quotes.txt here. I can do remove quotes.txt. And now if I do an ls, it's gone. So this was this was quick and powerful. That file is gone. It is not, there is no undo, there is no control Z, there is no rescuing this. It's gone forever. So I think every person who's ever had to learn the command line has gotten the Spider-Man. With great power comes great responsibility. And it's true, the command line is very powerful, but that also means that you can just do things, and if you didn't mean to do them, it can be very bad. So remove is a powerful command. You want to be thoughtful when you use RM, just because once things are gone, they tend to be gone forever. If you are on a server at your university or on Exceed or something, you might want to inquire about the possibility of backups and restorals, which may or may not be available. Probably not, especially if it's something you have just created. So yeah, be thoughtful about remove. And there is one thing you can do. You can just get in the habit of using rm-i, which is a way to force the shell to ask you, are you sure? Are you sure you want to remove this? So at this point, we could do rm-i. Let me see where something is we can remove. Oh, let's remove some of those pizza files that I created. So I can say rm-i thesis pizza.cfg. And in this case, instead of just removing it, which it would, if we had not used the -i, it would just be poof gone. Instead, the shell is going to say, hey, do you want me to remove this regular file? And at this point, you can say yes or no. And if you hit Y for yes, then it'll be gone. And at that point, let's try removing the other pizza file. If you say no with a lowercase n, and you go look in the thesis directory, pizza2.cfg is there. So it can be nice, it can be really nice to get into this habit of always including the -i flag, just so it forces you to think through one more time. Are you sure? Are you sure you want to remove this? Oh, another thing. Let's say we wanted to remove a folder. It might seem fairly obvious that you would just say rm thesis, but remove it does have this one little tiny built-in feature to make you think about removing a whole directory. It's not going to let you remove it with just rm. You actually have to use the -r flag for recursive. And that means I'm not just removing this directory, I'm removing all of its contents as well. So that just looks like a -r. And poof, it's gone. So again, it's really easy to delete things without meaning to, so be careful. I always have to tell the story of I hired an undergrad to work in my lab, and at some point I came in and it was just like his shell was just saying, you don't have permission to do this, you don't have permission to do this, you don't have permission to do this. And I realized he had actually typed rm-r/, and he had attempted to delete the entire operating system, like the entire file system. And so it was really good at that point that we had permissions set up and he was not able to actually delete our entire file system. So just a funny story. He was very embarrassed and everybody made fun of him in the lab for a very long time for that. So again, this is why this is a super wonderful sandbox, because you can delete everything. You know what? It's not going to hurt CyVerse. It's not going to hurt you. You could accidentally delete everything and you'd be just fine. So great place to practice your command line and get a little bit more confident before you start working with your own data. Let's talk a little bit about operations with multiple files and directories. So sometimes you need to copy or move several files at once. This can be done by providing a whole list of file names or specifying a naming pattern using wildcards. So let's start with just using multiple file names. Let's go into the data directory. So if we do an ls here, you should have something called data. And if you do an ls/f, you can see that it is indeed a directory, so you can cd into it. And for me, it's just absolutely habit. As soon as I cd into a directory, I type ls. It's like rote. I'm always like, what's in here? What's in here? So so I cd'd into it and I immediately typed ls to see what kind of files do I have in here. Let's say that we want to back up 2 of these files. Not all of them, just amino acids and animals. First, we can make a directory called backups. And now we can copy our 2 files. Now, there was an interesting question right before break about tab complete. And I think this is actually a pretty good example of how tab complete works, to get a little bit more in depth about the awesomeness, how smart tab complete is. I'm so impressed with how smart it is. So I want to copy some files. So I can tap A and hit tab, and nothing happens. And the reason why nothing happens is because the shell is smart enough to say, there's a bunch of A files in here. I don't know what you mean. You haven't given me enough information for me to tell if you mean animals.txt or animal counts or amino acids.txt. Like, I just don't know what you mean. So then you can say, okay, well, I'm trying to get to animals.txt. So you can type an N and hit tab. At this point, tab complete, again, is really smart. It says, okay, well, AN, I know enough from this list to know you must mean animal something. You either mean animals.txt or animal-counts, I don't know which, but it goes ahead and it fills in as much of the file name as it can assume from what you've given it, and it just pauses. So again, it's just waiting on some more input, and we actually want to do animal.txt, so I hit a period. That completely differentiates. No other file in this directory is going to match animal dot. So if I hit tab, oh, it didn't work. Okay, oh, animals. Tab complete will not work if you don't do it accurately. So animals, S period, and I hit tab and it completes. So tab complete isn't working. It's usually you, not tab complete, because tab complete's really smart. Again, I know for amino acids.txt, to make that unique, I'm gonna have to type AM tab. And that's unique enough for the tab complete to figure it out. So somebody asked about that earlier in the chat, so I just wanted to give a little more detail about that. So we've actually given 2 files, and then the very last thing for this copy command is where we want to copy it to. Oh no. Okay, hold on. I'm going to hit Control-C because my terminal wrapped around, and I think I'll probably have to do resize. Let me see. Okay, let's see. Maybe with a little more room, it'll fit. Copy amino acids and animals.txt to backup. Okay, so earlier when I was trying to type this, it was like wrapping back around on itself. And on my server, I can fix it with resize. I don't know how to fix it on the server, so we'll just have to, we'll figure it out if we need to. Okay, so now if I look inside backups, I can see that we have copies of animals.txt and amino acids.txt. So the pattern here is copy as many files as you want, and the very last thing has to be a folder. This can be an absolute path to anywhere in the file system. It can be a relative path. In this case, we're using a relative path. So we're saying the folder that you can see within this directory called backups. But you could have 4, 5, 6, 7, 8 files as long as the very last thing is the location of where you want them to land. What if we gave it 3 file names? I mean, can we even imagine what that might look like? So we could say, like that. It's going to give us an error because it can't copy 2 things into 1 file. That's not how the copy command works. So it always has to have a folder at the end. Oh, did we do up arrows and down arrows? I don't know where that is in the lesson. Let's do it now, because this is maybe my second favorite thing after tab complete, is up arrow. And so if I hit the up arrow, it gives me back my previous command, which means I don't have to type. I can just edit it, right? Like, so maybe I just want to make a few changes. Maybe I didn't spell it right. And I don't have to retype the whole first part of the command. You can also add things. So at this point, if I want to make backups, I want to copy all three of these things back, these three of these files to my backups folder, I can just add that. And you can, it's not just one command, you can actually scroll back up through all of your previous commands and then hit enter and run that command. So up arrow, super useful. Check it out. Again, anything to save on typing and make you faster is better. Okay, another super great way to get faster at the command line is wildcards. And this is pretty intuitive to most people because you've probably seen it as part of like Google searching or other type of searching, except it gets a little, so I have a sick dog in my house, so if you hear coughing in the background, he's, that's what it is. If we make it through this whole lesson without dog barking, it'll be a minor miracle, but at the moment it'll just be a little bit of coughing. So sorry for that aside, possible distraction. So wildcards are really useful. The most common one is a star, right? Like we probably have all seen the star as a wildcard, and it matches 0 or more characters. So a star can expand to mean no characters, 1 character, 3 characters, and any character. It's really flexible. So let's actually back up one and then go into the molecules directory. So that says go up a directory and then descend back down into the molecules directory. You can see basically that just bumped me over into this folder. So the ... went back to AG2PI workshop, and then the molecules pushed me down into the molecules directory. So hopefully that is starting to make sense with the relative paths. And if I do an ls here, we've got lots of files named PDB, which I think probably stands for Protein Data Bank, and some kind of information in these. Let's say if we wanted to see every file that ends in .pdb, we can say star pdb. ls lists to me all of the files that have some number of characters, any number of characters of any nature, followed by pdb. And it will give me back all of those. However, let's say I only want the ones that start with the letter P. I can hit my up arrow, get my command back, and add P. And so now my command is saying, list to me all of the files that start with the letter P, have some number or no characters in between, and then end in PDB. So in this case, I only get pentane and propane. I don't get octane or methane or ethane because they don't start with P. So that's probably pretty intuitive to a lot of people. The one that's useful but a little less intuitive is the question mark. The question mark is also a wildcard in Shell, but it only matches a single character. So let's do ethane, if I can spell it correctly, .pdb. So that only matches methane, .pdb, because this little question mark can only expand to fit 1 character. It can't expand to fit, this expanded to fit lots of characters, but this one is only going to expand to fit a single character. And indeed, it has to be a character, it has to fit 1 character. So ethane.pdb was not returned because there's nothing in front of it to match that question mark. And we can also combine these in various ways. So if you know you want 3 characters followed by ane.pdb, you can put exactly 3 question marks. And anything that had 4 characters ahead of the ane would not match. So this is kind of a deep cut. This might not make sense to you right now. I will say it just because it can help you diagnose some weird behavior later on. The way the shell works is it actually looks at this and it evaluates this expression first. So it expands this to all of the matching files, and then it gives that list to the ls command as an argument. So ls itself is as a little program that lives in the shell is not evaluating the wildcards. It is accepting the expanded list. And the reason why, it's kind of like order of operations in math, where you have to do like, you know, multiplication takes precedence over addition, and you have to do things in the right order to get the right answer. That's kind of how the command line works too. So if you're ever using wildcards and getting really bizarre behavior, just keep in mind that that wildcard expansion is happening first. And then that list of files that matches is getting passed to the command. Off the top of my head, I don't have a good example of when that causes weird behavior, but I have definitely seen that before. And been like, oh, right, order of operations, the expansion happens first. There are a whole bunch of exercises listing to see what files match a pattern. And they're pretty straightforward to go through. I'll do the first one while we're here. Star T star ane.pdb. So for the exercise, I would recommend you just try to answer it, try to figure out what you think the command line is going to tell you. And then you can type it in and hit enter and see what it actually tells you. And make sure that sort of everything's clicking. And if there's any questions about how those work, you can always ask us over chat or ask us during a break. So we've actually kind of gotten through a lot of the material prior to getting to pipes and filters. I think we should quit a little, let's take a break a little early. But I think it'd be cool if you guys maybe took 5 or 10 minutes. Like maybe we'll take a little bit, Ryan can chime in if he agrees. We could take a little longer break, like a 20-minute break, and give everybody a chance to go through and try a few of the exercises. Like especially if there were things that Ryan and I talked about that you're definitely a little fuzzy on, you could go try the exercises and then ask us in the chat if you have any questions. I think like not just listening to us talk at you, actually getting on the command line and exploring a little bit is such a critical part of this process to get comfortable. So what do you think about that, Ryan?
Yeah, so we're coming up on our hour break at the hour. So it's 11. It'll be almost 11 a.m. Arizona time, which I think is like 1 p.m. Eastern.
Yep, it's 1 for me.
So please take a minute to give some feedback on today's morning session. Tina posted a link to that form. And so there are a lot of exercises in the Read the Docs for you to work through on your own. And the solutions are hidden, but they're there on the page. You just have to click the little arrow next to the word solution, and you should be able to see what the answer is. I took the time to write out all of that in the Read the Docs for everybody. So yeah, it's one thing where it just kind of takes a little bit of practice. So if you want to spend a little bit of time in the break exploring some of the questions we just finished what would be in the navigation bar, the navigating files and directories and working with files and directories, as well as the introduction. So we finished those first 3 sections of this. And we might not cover everything in the shell lesson today. So this material will still be up here. Feel free to email and ask questions about things that we don't get to. I'll try my best to answer as timely as possible. So this is like a lot of material thrown at you. Like Meg said, we're talking and we're live coding and trying to follow along with that while also learning it can be a bit difficult at times. So yeah, it's just, this environment will still be available for you to try out and use. So like everything that we've gone over will persist after the workshop is done. So you can go back, look at the videos, catch something that you missed, go through the exercises that are on the Read the Docs and try things out. And you can still use this RStudio environment to do all of that stuff.
Great. So I guess, yeah, let's take a break and reconvene in about an hour.
Yep. And feel free to ask some questions in the chat. We'll hang around for a bit. Somebody that's helping will be here throughout the whole break.
Or you can unmute and ask questions too.
Yeah, that as well.
I have a question, Ryan.
Yeah.
So I work for USDA ARS. So is that the reason I'm able to sign up for this workshop, or anybody can sign up for CyVerse workshops?
I believe that anybody can sign up for these workshops. I'm not sure exactly, maybe Tina or Mary Margaret would know what the licensing is, but as a government entity, you're able to use CyVerse for doing your research for sure.
And how it will affect my access to CyVerse resources?
Is anybody from CyVerse?
I'm still here.
Okay, cool.
Hi, Raman. Right now, CyVerse is open to anyone, right? And so you do have to get an account, and it's free. And as we mentioned yesterday, it comes with a minimum of 100 gigabytes of data storage, and then you can up more with active analyses and things like that. And if you really get into the big, there's more. As far as there are certain limitations on certain types of platforms, like we have a cloud for virtual machines and things, and that's limited for teaching purposes, but to only US PIs. Connect HPC through XC is also, I believe, limited to US PIs, but if you're part of a collaborative team with a US PI, you might be able to share that. Do you have something specific? And I'm trying to think who else is on, or see who else is on who might pitch in if I hear you.
Well, I think he had mentioned that he was at the U.S. Department of Agricultural Research Services.
Okay, yes.
So yeah, you should definitely be able to access the resources.
Okay,
yes.
So if I have
Recording and share my screen. So we're gonna start going over pipes and filters. So you might have heard people in a meeting sometimes say they have a pipeline for data. And that's where this phrase comes from, this pipes that we'll be discussing right now. So next time somebody says that you have a pipeline or they have a pipeline, you kind of know where it came from. So first, we're going to start in the AG2PI workshop directory. That'll be our working directory. I'll just make sure that we're there. And then let's list the files inside the molecules folder, like we did before the break. Okay, so we have these files here. And let's change into that directory with cd. So using some of the commands that we learned about before the break, we're going to learn a new command right now, which is called word count, or WC. And so we're going to run that on the cubane.pdb file. And what the word count is going to tell us, it's going to tell us a few things. So first, it is going to tell us the number of lines in the file. So there are 20 lines in the file. And then the second item is the number of words, which would be things with a space in between them. And then the last number will be the number of characters in a file. So now if we run this with one of the wildcards that Meg mentioned before we broke for an hour. So if we do word count again with star.pdb, we'll see the word counts for all of the files with the file extension .pdb. So what if we are just interested in making sure that we have all of the lines in the file? Well, there's a flag with WC, which is -l, lowercase l, and that will only report the number of lines in our files with this wildcard. Number of characters includes the spaces, I believe. Meg, correct me if I'm wrong, but I think it's, yeah. So it does include the spaces in the file. So it's anything that the shell will recognize as a character will be counted. And then for the lines, it's anything that has the new line where the shell would recognize that a new line is supposed to start again. So then we can also try this with the -m, which will show us the number of characters per file, which includes the spaces. And then we can run this a third time where we use the W, which will tell us all of the words. So anything in counting everywhere there's a space in the file. And so this is a way of us to break up this command that would give us all of these values into the ones that we want. So this can be kind of this is a kind of a useful command when you're checking on your files to, like, say you have a data set and you can't remember if you recorded 200 observations or 180 observations, but you know they're on all of the lines. Each observation is on a single line in the file. So you can use the WCL to count the lines in the file, just to make sure that you have, the appropriate number of lines in your cubane, ethane, methane, octane, PDB files, so that you have all the information that you need to do further processing with different programs. But one of the really cool things that we can start to do is we can add files themselves that don't exist yet as an argument to this. So if we wanted to take our length word count, so if I use the up arrow to go back to what I typed in, like we did before the break, I can create a text file by running this command and just say, I want it to be called lengths.txt. Now I get this error that says no such file or directory. So what you actually need to do is to put this greater than sign, which redirects the output instead of printing it to the screen into the file. So see, now we don't get a no such file or directory error message when I run the command. And if we run ls, we now see that there is a lengths.txt file. And we can print this to the screen, let me clear my terminal so that this is at the top for us to more easily see. And we can type cat lengths.txt. So this prints out what we saw with the word count length command. So we'll keep using cat throughout the lesson for a little bit of convenience. But there's other commands that do similar things. So you can use the command less on lengths.txt, and then it'll just show you that. And then it'll say end, and you can enter, or rather Control C to exit that. Or sorry, Q to quit. My apologies. So if we run less lengths.txt, it takes us out of the shell, brings us inside of less, which lets us view the file, and then to get out of this and back to the shell, push Q. So now let's learn another command. Let's try sort. Try sort lengths.txt. So if you notice, when I run sort on lengths.txt, it puts, despite methane having less lines, it puts that last. And then it starts with ethane, propane, cubane, pentane, and octane in that order. Can anybody take a guess as to why that might be happening? Why it's sorting this way? Like what might be causing that behavior? Just feel free to unmute yourself or type it in the chat. Or if you say, or if you just type, hey, can you just tell me the answer? Then I will just tell you the answer.
It's because it's ordering by the first digit that it's encountering. So it's, if you look at the first digit of each of those lines, it's still 1, 2, 3, and then 9.
Yeah, that's exactly right, Miranda. So what it's doing is it's looking at it alphanumerically. So if there was an A at the beginning, then that would come last, and it would put the numbers first. So if we want the sort command to work with numbers, we need to specify that with the -n flag for numeric. And then if we run that on lengths.txt, so use tab complete there, now it's in ascending order from the smallest number of lines to the largest number of lines, and it still gives us the total number of lines. And notice how the total happened at the beginning, and now it's actually happening at the end. So it's sorting it by the numbers first. So now what we can do is take this sort lengths, again, can't just put a space in there. We'll have to put the greater than sign to store our output into a new file where we've sorted the lengths of our files, including the total number of lines, into sorted lengths.txt. So now if we run ls, we can see that we have the sorted lengths as a text file. But let's say that we don't want to open it with less or run cat and print all of the output to the screen. Let's say that this was actually a really big file that we're just interested in seeing that the smallest item is first. We can use the command head, which is short for the beginning of the document. And if we say -n, so this is the number of lines of the file that we'd like to print. Let's say we just want to look at the first one, the first value. Sorted lengths.txt. And this will just print out the first line of the file. So this is the head. There is also a complementary command called the tail, which will print starting from the last line of the file. So we can see what the biggest numeric value is, which would be the last one to appear in our sorted file, which is the total number of lines. So these, the head and tail, are really good for just checking large files to make sure that they're there. So some of you might be doing sequencing, and you might want to just make sure that you have in your sequencing files the different sample name lines are in there, or that it looks like the output looks normal for the format that it should be in. So this can be really, really great for when you transfer those big files, kind of spot checking it and say you want to look at like the first 4 lines of a file just to get an idea. Then you can look at the first 4 lines of whatever file it happens to be. So we've used the operator greater than to assign the output to a file. And I apologize that this is not correct in the documentation. I'll fix that and update that on the website. There's another operator where we could say that we want to create, let's create a new file with a new method, and then I'll show you how to append the output with a different operator. So let's learn the command echo. So echo will print this text. So echo just printed the text that I specified. So then if I say echo hello, assign it to test file.txt, we can see that we now have this test file.txt. And if I use the head command on test file.txt, it'll print it and say, print the contents of the first line, which says hello. So if I add this and I say echo hello, and I put 2 greater than signs, which is shorthand for append to test file. Now, if I use cat to show all of the contents of test file, you see that now it's added another line. So the append with the double greater than signs will add the contents at a new line in the file. So if we run head, where n equals 1 on our test file.txt, it'll just return the first line, hello. Let me clear the terminal. So if we go back up one directory with cd ... So let's list the files. Okay, there are creatures. Let's see. Oh, sorry. Let's go back to the data directory. List this and see that there is animals.txt. So let's use that. So let's try subsetting this with, we'll take the first 3 animals and let's put them in animals subset text. So now if we look at with cat at animals subset.txt, it will show us the 3 lines that we subsetted, and we can check this, that this is actually what we grabbed by running the head command. You see those are the same things, so we've just redirected that to a text file. We can do the same thing with tail. We can do redirects. But we can also start using this symbol, which is called the pipe, to put commands together. So let's clear the terminal real quick. And so if we go back to using our lengths.txt file, we can find the smallest in 1 line. So this will sort the text file, and then the pipe symbol right here, which is this vertical line, means that the shell will run this, it will evaluate lengths against sort, and then it'll pass the sorted text to the head command as the input, even though we didn't specify it, and it'll only print out the first line. Oops, that's in the molecules folder. Let's change that, change to the molecules folder, and we'll try running that again. And you'll notice that I forgot the -n flag. So it output the total length because it's sorting it alphanumerically. And now with the -n flag in place, I'll get the smallest file, which is methane, or the smallest number of lines. So pipe is a really cool little feature when you are looking to do more than one thing at once. So we could look at all of our protein database files without actually creating a text file to check on the length. We can do that by creating a pipeline with wc-l, and then we'll use the wildcard.pdb, and then put a pipe, sort-n, put numeric, and we'll get the same output that we did when we created the lengths text file and then sorted that and stored that as the sorted lengths text file. So you can keep building off of this, and we could say, without creating any intermediate files, any outputs along the way, we could go back and do the same thing of extracting that smallest number of lines from our group of .pdb files. We go back and add another command to our pipeline, and we'll add head n1, and we'll just get the smallest number of lines. So this is a really cool. There's a nice diagram in the read the docs that I'll copy the image address and I'll put it in the chat, because it's a really good way to visualize what I just walked through. And so this is a really cool feature because it's not exclusive to the functions or programs that are in the shell itself. If you have like programs that are installed on your terminal that are not the ones discussed here, like say you have something that's doing an analysis and you know that what the output is going to look like, and you want to sort the output of that analysis and then store that in a text file, you could do that. Like you just have to sort of think about, well, how am I going to structure the commands? So like if I did still want to take this and store it as a solution, I can say, we'll call this solution.txt. Nothing prints out. We can look at solution.txt, and it'll give us the answer from our pipeline. So using the pipes to string together commands and this redirect right here to store it in an output file format that matches what you're doing. Super, super powerful. It's very interesting once you start to, this is the easiest way to play around with this, is like using these bash commands. And then I think once you start to get an idea and a sense of the syntax of everything, so like if I go back to this directory and I see, I'm in AG2PI workshop and I'm going to go to data and I'm going to list there. And so we have this animals.txt. So let's list the files again. So it's at the top. And if we wanted to, we could print the animals.txt to the screen. And then we could say we want the head of the first 5 lines. And then we want the tail of that command. And then we want to sort and store that as final.txt. So take a guess. just think about it for a second. Think about what is in here, what I'm doing. Maybe run through each of the commands individually to see what that would look like if you ran them individually. And then think about how it'll be different when you put the pipes together. So let me run this. I'll take a look at what this looks like. So we have our animals.txt. You can see that it took the top 5, 1, 2, 3, 4, 5, and then it took the last 3 of the top 5. So you can see I have the top 5 right here. So then it only took these. It sorted them and then stored it in the final file. And then if we go to sort help, you can take a look and see that the -r is sorting in reverse. Give everybody a minute to sit and digest pipelines and filters. And then I'll move into another bash command. Okay, so if we notice in our animals.txt, let's just print that out with cat. So that there's a comma separating what appears to be a date from the animals. Maybe these are observations. You saw a deer, a rabbit, or raccoon on that date. And you're just kind of cataloging these like you might do in a wildlife ecology study. And so what we can do with this next command is, say we were only interested in the animals. We really didn't care about the dates. So we can use cut, the cut command with -d, and this stands for delimiter. So in a CSV file, this would be the comma. It could also be a tab. It could be a space. It could be any character really, but the tabs and spaces and commas are probably the most common that you will encounter. In this case, it's a comma. And then we need to specify, now that we've told it where our fields are by the delimiter, looking at this, you can think of this like a spreadsheet. Spreadsheet columns are equivalent to fields. So we have like one field here and one field here. So we're interested in -f field number 2 of animals.txt. So now when we run the cut command, with that, we just get the animals. So now let's say we've conducted our study, we've got our animal observations with all of these dates. And now what if we're only interested in the unique animals in alphabetical order. So we can do that with pipes. We can say pipe sort. So this is going to alphabetize what we've created with cut. And then we're going to say unique, which is a new command. This is only going to return the unique character values. So up here you can see that rabbit and deer are repeated twice. Now it gets rid of the repetition and everything is in alphabetical order. So we took those 8 lines of data, we cut out the text that we were interested in, which was in field 2. So let's just take a look at that. So we cut out everything before the comma and returned just the unique sorted values. So what do you think we might do to return a count of our unique animals? Do you think we would count with sort or unique, or would we have to add another pipe with WC-L? Would you drop some answers in the chat that you think might be how we would count the number of animals of each type, and start to make a data set that you might have for like a accounts file. Like if, say, you wanted to compare the relationship of how many of each animal over the whole study you had. I also just realized that I asked this question and I did not hide the answer in the read the docs like every other question. So it is there. So I'll just go over the answer. So we can do our counts by adding the -C flag to unique. So if we run that, it will tell us how many times the bear, the deer, and the rabbit, and the fox and raccoon appear in our data set. So our data set is 8 lines long. So each line is 1 observation. So all of these values should equal 8 when you add them together. So this is another useful tool for checking on the data that you have. And there's another example listed in the read the docs that you can work through on your own, where it's talking about inside the North Pacific Gyre directory, there's a scientist named Nellie, and she is trying to find which files have missing observations. And so that's really good practice for putting together the pipelines, and I'll leave that for you to explore on your own time. And we'll keep moving forward. I'll give you like the next 10 minutes to kind of play around with this and ask questions. And then we will, I believe we have another break scheduled. Yes, we'll have a 10-minute break at 10 to the hour. So we'll have 10 minutes now for you to play around with these commands, ask questions. So if you don't use the sort command, I get an output of one animal name for each line. So if I'm understanding that correctly, you ran this, Miranda? Yeah, so that is, I think what that's doing is it's going line by line. I think that there's 1, 2, 3, 4, 5, 6, 7, 8. Yeah. Yeah, so the sorting things alphabetically helps. Maybe Meg can clarify on like why exactly it behaves that way. But I think it has something to do with how the shell looks for things when you're asking it to do the unique. I think it goes line by line, and if it sees things are on like appearing on the second line and then the third line and then the fourth line, then it'll count those as the same thing.
Yeah, I don't even remember unique adding numbers. I was just gonna like log onto my server and see if it does that because I have no memory of this being adding numbers before the lines. I just remember it deleting the lines.
Well, I think that's a good point too. So like Meg and I have both been using the command line for combined time a very long time. And you always find new things, right? Like there's so much inside of all of these different functions that it's like you can learn stuff from everybody just by talking about what you tried in the command line, because there's so many different possibilities, especially when you're using pipes to string things together. Like you'll find things that like Miranda found. Like I had no idea that behavior happened in the shell. Like that's a cool little thing to know. So
yeah, I think this is a terminal, and this is the other thing. Like all shells are not created equal. Like they're like 98% similar, but then you'll find these little gotchas because like I do not get numbers in front of lines on my Linux server when I type unique on a file. It's just a slightly different output. So
with the dash C flag.
Oh, I didn't test that one. Oh yeah, with the dash C I do. I guess I never used dash C. So this is such a good like segue, because every time I'm building up pipelines, I test every individual component to make sure that I like fully understand what it's doing, because you'll get weird. If you get weird output at the end, like that's just how you have to go back and like look at each one. Yeah, okay. That's why we're getting the ones. Yeah.
But yeah, I was talking to my partner over lunch, and they were asking about Unix, and I'm like, well, I think all of the people that are experts on this are like in their 80s. Like the people that like wrote this from the beginning, they have since passed on or are very old at this point, and they would know this most in depth. So it's like a very, very deep ecosystem of commands to learn over time, and you'll find the ones that are useful for what you do as you play around with it.
So it's coming back to me why you get the ones. This took me a minute. With the unique, it's only two lines that are next to each other that are exactly identical that get collapsed. And the reason why it does this is actually really clever. Let's say you had a file with like 1 million lines. If it had to sort those lines and find all the ones that were duplicates, it would be very, very, very slow. So instead, it's kind of a lazy program. So if you don't do the sort, it only checks, is this line identical to the next line? If it is, remove the duplicate. Is this line identical to the next line? If it is, remove the duplicate. So even if two lines are duplicates, but they're really far apart, Unique won't find them. Does that make sense? So if you take the sort out, that's why you get that behavior. Sorry, it took me a minute to remember this.
And I think that's also like we talked about at the beginning of today about how this was invented in like the late 60s, early 70s. And so like doing little tricks like that back then was like a huge, huge time saver, just to make sure that you weren't going to tie up a computer that was the size of a house for a day because you wanted to look for the unique attributes in the computer system.
Yeah, computing time used to be a lot more precious and expensive than it is now. But you know, genome to phenome, that's what you're here for. You're going to be working with really big data sets. So sometimes these little things really matter for how fast your pipelines run. And that's, you know, sometimes you have to do some digging to figure out how these commands are going to work with such large data files.
Does anybody else have any questions? Feel free to put it in the chat or unmute yourself.
And if anybody just is having like a particular problem with or is stuck, if you want to just direct message me or one of the other people who's helping out, we can pop into a room and get you sorted out or re-explain something, because I do realize this is a lot to absorb really fast.
Okay, and now we're at 10 to the hour. So I'll pause the video, or the recording rather, and we will take a 10-minute break. I'll be back in a few minutes if anybody has any questions. And then we'll get to the final lesson of today, which is how to find things.
Hi, everyone. If you can hear me, we're going to get started here in just a few seconds. So come on back. We've got a little bit more to do. And the good news is I think we are going to have enough time to go over a few things again, or dig into any questions you have at the end of this, just so you can get your specific questions answered. While we wait for everyone to come back, I'll just talk a little bit. I have to say, it's hard for me to do these online. I really miss the in-person experience and being able to talk to you during the break and hear how it's going. And usually we have people like walk around to each person and make sure, you know, what's working, what's not working. So not having that ability is really, it's not great. So, you know, if you're finding this difficult, that's not a surprise. And please don't be too hard on yourself. This is fast. And I have a lot of biology students that learn computation, and this usually takes a few times through. It really does. It's maybe watch it once, sit down and try to do some things on your own, and then go back and revisit the pieces that you need. Is my recommendation. So if you're a little overwhelmed, definitely you're not alone, and don't feel bad. You can get this. It takes practice, but it, you know, it's doable. It just takes a little time. Be kind to yourself. Okay, so I really like getting to this part of the workshop where we get to learn how to find things. And I find it really useful because I am not always good at remembering where I put things, especially when you have lots of files and lots of folders. And earlier I was showing you my desktop, and that may have been a good indication of how good I am at organization. So being able to find things on the command line is really useful. And we're going to learn how to both find words inside of files and also find files based on their name. So these are both quite useful. And very analogous to having, you know, the little search glass on Apple, or the search function on Windows to search your whole computer. So definitely really powerful. Let's see. I am starting out in input AG2PI workshop data. So I believe this is where Ryan left off, but if you're not here, please CD to this path. And if you do an LS, actually, let's back up one. We're gonna start out at input AG2PI workshop. Okay, so we're gonna start learning this command called grep. And grep has a really unfortunate name because it's, you know, at least copy sounds like what you're doing, or move sounds like what you're doing. Grep is like, what is this word? It's not a word. And it really means search, but it stands for global regular expression print, which, let's be honest, is really not helpful at all for memorizing the word grep. And we'll talk a little bit more about that. It's kind of one of those legacy things that maybe made a bit more sense when those early programmers were first writing Unix, and is now pretty meaningless to most of us. So this is one of those things to like write off to the side on that piece of paper that you've got going, and write search next to it, because that's what it means. Okay, so we're gonna look at this haiku. So let's CD into the writing directory. If you do an ls, you should see that we have this haiku.txt file, and we can take a look at it with the cat command. And you might have to scroll up and down to see the whole thing. I think it's about 11 lines, the file. And cat's another one of those ones that I feel like is a little counterintuitive, like what does cat even mean? And that's short for concatenate, which is still, again, still not helpful because concatenate, I think, of like to add two things together. And that is what it's doing. It's actually adding the text to your terminal. So if that whole reasoning helps you to remember the word cat, great. If not, write it on the sheet and keep it handy. So this is a short file that we can just play with to learn grep. Let's say that we want to find lines that contain the word not, N-O-T. We can type on the command line down here, grep not haiku.text. So similar to a lot of commands we've seen earlier, we're actually giving it two different arguments. The first argument is the thing we want to search for. And the second argument is the file we want to search in. So order does matter. If you put the not at the end, it won't work because not's not a file, if that makes sense. So order here, start with grep, which means, hey, terminal, please search for the word not in the file haiku.text. And this worked pretty well, right? So the first thing to note is that it gives you the entire line. If it finds the word not on a line, it gives you the whole line. It doesn't just return the word not, or it doesn't return the whole file. It is grep specifically returns lines by default. And we've only got 3 lines out of the 11. And let's try another example. We could search for the. Again, and don't forget your tab complete. So I just typed HA tab. It's not that I'm a super fast typer. I'm not. It's that tab complete becomes a way of life after a while. Okay, so in this case, this line makes sense because the is definitely there. This line, we also found the, but it's part of a word. Maybe we don't want that. Maybe we actually want the as a word all by itself. Well, you will probably not be surprised to learn there's a flag for that. There's always a flag for like almost everything you want to do. That's like the great thing about Linux. So we're going to add the W flag. And W means pay attention to words. Search for whole words. And that means that we're going to look for the word the, but only when it appears with white space boundaries. So what we're saying by it needs to be a whole word is that we actually don't want the word thesis because there's no space between the E and the S. The is not its own word. So that's kind of how the program figures out, okay, that this doesn't qualify. And so we can see that that worked. And this time we're only getting this single line instead of both lines. We can also search for a phrase, which is pretty useful. Sometimes you want multiple words. Again, we're going to go ahead and use that word boundary flag. So we want the thing that we're searching for to have white space on the beginning and the end. Oh, and I guess white space is kind of a computer sciencey term too. To back up, sometimes I use this terminology and I forget that that may not be obvious. So I mean, white space in a file is not just like a space bar space. It can also be a new line or the beginning of a line. So it does make sense to think of it as like anything that would like separate a word from another word. That could be a single space, that could be a new line. In computer science, you also often hear that referred to as white space. Nothing in it. You can't see, it's not a character that's printed. It's more just blank. Okay, so in this case, we're gonna search for a phrase, is not. So in this case, if I put is and not without quotes, it would be confusing because we wouldn't know that I wanted to search for both of those things as a unit. If that, I'm not trying to search for the word is and the word not separately, I'm trying to search for the phrase is not. And to communicate that to the grep program, I'm going to surround my search phrase in quotes. So that allows me to include white space inside the quotes without being interpreted on the command line as different arguments. This is one of those things you have to kind of get used to thinking about on the command line. So this worked. We got is not. So the terminal knew, okay, this is a whole thing. I'm not trying to search for this and then trying to search for this. Because all of this is enclosed in quotes, it knew to search for the whole thing. And again, grep's still giving us the full line that matches, not just the individual part that matches, but the full line. One thing that I use all the time is the N flag. It will print which the actual line number that goes along with the line. So we can search for it. We're not asking for word boundaries. We're just saying anywhere in the file that I and T occur together inside a word, as its own word, whatever. But we want the line numbers to be added to our output. So this is telling me line 5. We've got it embedded in a word here. Line 9, it's its own word. Line 10, it's its own word. And we've seen this so many times today. You can combine flags. So if we add the word boundary flag and the line number flag, we get both. We get the line numbers and we're only getting it when it's its own independent word. And I think we've seen this. You can also just smush them together. So if your flags are single letters and they don't really have arguments, if they each needed their own specific argument, this would be a problem. But since they're just single letters and they're just hanging on their own, we can smush them together to kind of save a little time. And it works just as well too. So I think, you'll see that sprinkled in and out of this lesson. Sometimes they're separate, sometimes they're together. And that's just a kind of a shorthand, like a contraction that you would see in English. Okay, we can also make our case search insensitive, which is useful if you know you want a word, but maybe the word is sometimes at the start of a sentence, or maybe the word is proper, but sometimes, maybe somebody hasn't properly capitalized it. So in that case, we have another flag, and it's -I, and that means don't worry about case. If it matches uppercase, lowercase, or any combination thereof, please still return it. So I gave it a lowercase th, but we did get the same lines back that have uppercase th, as well as now we get the lowercase th's as well. Another super useful option with grep is V to invert your search. So maybe you want all the lines that don't contain a certain phrase. So that's pretty nifty. So in this case, it's all of the words, all of the lines that do not contain a lowercase the. So we want the line numbers. We're going to search for the with word boundaries. And then after we get done with that, we're going to invert the search and return everything that does not have the. So we're really piling up the flags here to get really specific and drill down to ask a very specific question of this file. So we are still getting capital D's, and that's because I didn't include the -I in this, but we could include the -I and get rid of these. That would make it case insensitive. But since I didn't include that flag, it is still case sensitive. But the lines with the lowercase the are all gone. And we even get the blank lines. So, the search will return blank lines because, they're definitely not going to have, they're definitely not going to be matching our pattern. And then this is very useful. And again, we've seen this all day today with this flag lowercase r. R is often used as a flag to mean recursive. And so that means that we can search not just a single file, but you can actually search through a whole set of files in your subdirectories. So we have, you can see that we have not just our haiku file, but we actually have 3 additional directories. And let's say we want to look for the word yesterday. We want to see if it's in any of the files in any of our directories. So anything below this point in the file system. So I'm going to say grep-r for recursively search for the word yesterday, and I'm putting a period. And we went over this earlier. The period means search starting from here. You could put a path to another directory and say, search this other directory. Or you can put a file. We've thus far, since we started using grep, we've been putting a file there. But if you put a location, in this case, the location, that period meaning right here, and the recursive is going to search all of the files in the folder you're in, as well as all of the files in all of the subfolders. So let's see what we find. And this is actually pretty nifty because recursive adds a little flair to your results, and it tells you where. So let's say you actually have hundreds or thousands of folders and files below where you're sitting in your directory tree. You don't want to necessarily, you might not want to know just that the line exists, but where does it exist? And so in this case, it's giving us some very useful information, which is from here, there is a folder called data. And in that folder is a file called littlewomen.txt. And in that file, there's a line that has the word yesterday. And it turns out littlewomen.txt has 3 different lines with yesterday. So we get them all back. And we also get back our haiku.txt, which is in the current folder. So we can see that this did go through and search multiple files in our file system. Again, that can be really nifty if you are looking for something specific and you have a big messy file system like I sometimes do. As you're probably picking up on, grep is this super useful, super flexible tool. There are so many flags. I had to laugh and be appreciative when Ryan at the beginning of today said, I will admit I have never learned all of the flags for LS. And I had to laugh because I don't think anybody, there may be a few people on earth that know them all, but there's so many. You just have to make the manual your friend, because it wouldn't even really probably be worth your time to memorize all of the flags for every Linux command. So the goal is really more to know how to find the help when you need it. So again, we're going to do this grep -- help. Always a great place to start. You can also just Google Linux grep manual page or Linux grep help. Sometimes that's even more useful because you'll stumble on a tutorial that's a little less verbose than the full help documentation. But let's check out the help documentation. As I scroll up, you can see there's just so many flags. And it's probably at this point worth mentioning that grep, the R and the E in grep refers to regular expressions. Regular expressions is its own language. And I tell my students, and they laugh at me, but I believe it's true, regular expressions will change your life if you are a data scientist. Because they're hard to learn, and there's lots of little special characters and nuances and gotchas, but they allow you to be the most powerful pattern search engine on earth. You can search for anything, and it's so flexible. And this whole language is called regular expressions. And we can see a little teaser of that. But that's why you're seeing this phrase all over the place, regular expression in the help documentation. They're assuming in the documentation that you understand what regular expressions are. You don't have to know regular expressions to make grep work for you. If you are searching for a word, that's fine. Grep's going to work with you. But if you want to start doing fancy stuff like, I want the word sequence, but only when it occurs at the beginning of a line, or I only want capital letters, words that have only capital letters between 6 and 9 characters in length. So you start to be able to build up these like really hyper specific search queries. Or I want exactly 3 numbers, 2 letters, and then the letter Z, and only give me back lines that have that. And this turns out, when you get really crazy phenotype data and genotype data, you often want to parse on these really obscure, specific, maybe sample names or whatever. So eventually, potentially worth digging into this. In the meantime, don't be intimidated by the fact that it says regular expression all over the place. Let's see, and I think we have a pretty good example of this. Grep, we're gonna say -E for telling it to use our regular expression, and we're gonna put our regular expression in quotes, again, to get the shell to interpret this as a regular expression, and it's not something it needs to do on the command line. Okay, so in this case, this is our little regular expression language. It's just to show you the power of regular expressions. Maybe this, if some of you, your interest is piqued and you want to go explore more. The caret means I only want lines that begin with, the period means a single character, any character, and the character O. So if you look over here, every line we got back has an O as the second character. So it anchored to the front of the line. That period indicates that there can be anything as the first character, but the second character has to be an O. So it's a little, it's very powerful, but you have to kind of memorize all of these little patterns, but you know, can be useful. Let's see. Yes, so you know, earlier I was trying to explain the order of operations in the shell. So I think my example, what's a good, ls star s, is that this is actually expanding the star s on the command line, figuring out that star s matches thesis and matches tools. It then takes those two directory names and gives that as a list to the ls command. And that order of operations is important. And that's exactly why we put quotes here. So you can get really weird behavior if we were searching for like star n. And there's definitely the letter N in haiku, but if we wrap that in quotes, I think it'll actually work. Oh no. Yeah, I'll have to think about how that works. Okay, but the point is, whatever you put inside the quotes gets sent as an entire argument to the grep command. But if you leave it without quotes here, this is going to expand and become a list of files, and that's what's going to get passed to grep as an argument, which is not what you want. So in general, if you're ever using a wildcard, like a star or a question mark, and you mean to pass it specifically as an argument, like you're actually trying to tell grep, like you're building a regular expression, you've learned the regular expression language, you definitely want a star in there, and you're trying to give that to grep as an argument, wrap it in double quotes. And then it won't expand on the command line to represent a bunch of files and then pass the files to grep, which is not the pattern. You're not, the list of files is not the pattern that you want to pass to grep. Again, that's a bit of a deep cut, like maybe a bit more than you're ready for, but let us simmer around in the back of your brain a little bit. And at some point, hopefully a lot of you will go on to kind of practice the command line and use it more, and you'll start running into this. And then it might click and you might be like, oh, right, this wildcard expands. And so if anything, if you have a star and it's behaving weird, you can revisit this part of the lesson and it'll probably be making more sense. Okay, let's, we can also use grep with pipes. Let's just see a really, really quick example of that. And I have to figure out where we need to go to find the animals.txt file. Okay, so I'm going to back up one, and I believe it was in data. So I'm going to change directories into data. And then I'm going to change directories into animal-counts. And here we have animals.txt, and I'm going to cat that to the screen just so we know what the heck's in there. Okay, so we've got date, comma, the name of an animal, comma, and a number. So maybe this was the number of times that animal was cited on that date or something like that. So we could actually filter, so perhaps you're a data scientist and you need to do something with the rabbit data. You don't care about the rest of the data, you just want the rabbit data. So this is a great use case for grep. We can say word boundary, search for the word rabbit, and just give me those lines. So that allows you to kind of subset your data down to something that you're more interested in. From there, there's a really nifty command called cut. This is this is only in one of the exercises, and I think they kind of expect you to go look it up on your own, but I'll just mention it real quick because it's pretty useful. So cut allows you to take particularly comma separated values. It's quite useful, but anything that is separated by a standard character, you can cut it up. So in this case, you can give it a delimiter. So in this case, the comma is the delimiter. The comma is what's separating the data into different columns. So I can imagine importing this into Excel. The delimiter would be comma. Excel would know to put all of the dates in the first column, the animals in the second column, the counts in the third column, and it would toss the commas away, right? Like once you import it into Excel, you wouldn't see the commas. So in cuts parlance, we would call that a delimiter. So D is the flag for delimiter. I'm just going to say my data is delimited by commas. And from there, with the -F flag, I can tell it what columns to keep. So if I just want column 1, I say chop my file up everywhere there's a comma. That indicates that it's a new column, and only return the first column. So now I'm only getting the date. So it chopped off the other 2 columns for me. And then let's say I really want the date and the count, but I don't care about the animal. I can give it kind of a more complicated argument to the F flag. I can say I want column 1 and I want column 3. I'm actually going to put a comma between those so it doesn't think I'm trying to ask for column 13, right? Like I need some way to show that 1 and 3 are separate. So in this case, it's a comma. Again, you can find all of this in the documentation if you forget, which is perfectly common. Most people do not have all of these things fully memorized. And so in that case, we're only getting the first column and third column, and it's gotten rid of the second column. So we learned a lot about pipes, and the cool thing is now we can start to combine our programs. So I said earlier, what if we only care about rabbit data? Well, I can say grep rabbit animals.txt. We can make sure, yep, that still works. I haven't forgotten it since earlier, which is a thing that can happen. And then I can pipe it to cut -D, comma is my delimiter, -F. And this time, maybe we only want the counts. So now I have kind of built up this little pipeline to filter for only rabbit data and then filter for only counts. And now we can potentially, sum this up and do something with it or put it into whatever software we need to analyze our data. So all of these things are very powerful when combined. Okay, so grep is, we've used it to look inside of files, but there's another really useful command called find. And find is really more about finding files based on their name. So we have a pretty complicated directory structure here. Let me go back. So I'm going to back up 2. So again, this means back up 1 directory and then back up another directory. So that got me all the way back to AG2PI workshop. And I'm going to CD into writing. Perfect. If you're following along on the documentation, there's a really great visual that you can check out. But we're sitting right here in this folder. So beneath us are all of these different files and folders. And this seems like a very realistic example of somewhere you might be like, I need to find something and I don't know where to look and I don't want to type ls 42 times and then attempt to explore all these folders. So find command is going to be your friend. So let's start and just run find with the dot again, meaning like right here, find what's right here. And it gives us this output that's it just tells us like, what all what is here? What are you looking at from here down? So every folder and file gets its own line. So it tells us there's a data folder. Inside that data folder is a littlewomen.txt file. Inside that data folder, there's also a 1.txt file. Inside that data folder is a 2.txt file. So just all the way down through all of these different layers and different subdirectories. So that in and of itself is actually quite useful. We can also filter for just find things that are directories. I really only want to know all of the directories from this point in the file system down. And for that, we can add -type D, which is a flag that's not a single, character. It's actually, you type out the full TYPE. And you're saying, I only want directories. And this time it's only telling us about directories. It's not giving us all these .txt files and other individual files. Instead, we can get type F, which is just the files, not the directories. I find this command in particular to be really frustrating because unlike other commands, I feel like the order of operations is a little reversed. We tell it where to look and then start kind of specifying what to look for. And so I think in every other command today that we've learned, this is really reversed, where we would have said find -type F, period. And I don't know if any of our helpers on have a good explanation for why find works this way. But it is a gotcha that gets me sometimes. So I just wanted to point it out. But you always you want to start searching from here, and then you start adding stuff to kind of determine what you're searching for and how you want to search. Probably the most common use case is not to filter for directories and files, but to search by the name of something. For example, I have a vague memory of making a file called something like this 2 weeks ago, and now I can't find it. Where is it? That is the optimal use case for this command. So let's say I'm pretty sure I have a text file. It's somewhere in this file directory, somewhere in one of these subfolders. I don't know where. Just show me all the text files. So in this case, I'm going to use the flag -name. And I'm going to use a wildcard and say return every single file that ends in .text. And I can look through them and see if any of them work. Okay, so this is actually not the behavior you want though, right? Because you're like, wait a second, there are other files, there are other .text files. Why is it not finding it? This is another one of those examples where the terminal is a little bit, it's doing things too early. So the terminal is actually taking star.txt and saying, oh, that's a wildcard. I should expand that to match all of the .text files in the current directory and just send that as a list to the find command. So this wildcard expansion should always happen first. And then once I get done replacing this with the names of the files, I'll send that to the find command. That's not actually what you want. You actually want it to interpret this. And to do that, we are going to wrap it in quotes. And this time, this entire piece of text with the wildcard gets passed to, as an argument, to the name flag, which all is being used by find to filter the results. So this quote, basically, it just means, please don't interpret this yet. Command line, hey shell, ignore this. I want to pass it to the find command. I don't want you to expand it yet, if that makes sense. So we've kind of seen a number of examples of that. Hopefully that sort of makes sense. Yeah, so if I did ls star.txt, it would give me haiku.txt. And so what happens up here, I feel like I'm kind of beating a dead horse, but I feel like this is a difficult concept to get. So what happened up here is this went ahead and expanded to haiku.txt. So what we ran was find .-name haiku.txt. So of course it's only going to find haiku.txt. That's all you're asking it to find. But we actually wanted it to do, by wrapping it in double quotes, is to search for all the .text files. So hopefully that makes sense. That's an important gotcha with the find command. Again, all of these commands can work with pipes, but another thing, let's see another way we can get the command line to interpret something, actually like perform, I guess it's a computation, and then pass it to something else that isn't a pipe. This is kind of a nifty construct. I'm just going to type it all out and I'm going to talk you through it. Okay, so instead of double quotes, we've got this new little construct that's a $, open parentheses, and then a close parentheses. And when you nest something inside $, open parentheses, close parentheses, the shell is going to interpret this first. It's just going to run this as though it's its own little command line and take the results and substitute all of the results here and pass that to the word count command. Again, this is very much like math, where you learned when you're looking at a bunch of numbers and there's parentheses and there's pluses and there's multiplication and there's division, you have to do what's in the innermost parentheses first and then move your way out. It's very similar here, where what's inside the parentheses is going to be interpreted first, and then the result of that is going to be handed off to the WC-L. So in this specific example, we're looking for all of the files that from this point in our file system down, all of the subdirectories, anything where we find a file called star.txt, we'll take that list of files and we'll pass it to the word count command while filtering for just line counts. So now we can see that littlewomen.txt has a lot of lines and our other files have relatively fewer lines. You can also, this is a great way to use find and grep together. So you would want to maybe match a pattern inside of, you would want to find a bunch of files and then only match a pattern in that set of files, right? So maybe you don't want to match the pattern in every file, just in certain files. So in that case, you've come, it's a little bit more of a complicated use case. You really want to use grep and find. So here's a really great example of that. Let's see, I think I need to get back to the PDB directory for this. So let's back up and go into data and go into PDB. Okay. So if you're following along on the command line, this is the path where we can find these PDB files. And we can look at one of them. And these are kind of interesting protein information, and it does give you the individual elements that are making up all of these different positions in this protein. So that's pretty nifty. So let's say we want to find all the iron atoms. All of these PDBs, which ones have iron atoms? We can grep for iron, but we can say we only want to find iron in the files that are named with PDB. And that tells us there's a heme.pdb and it contains an iron atom. Great. And if we, maybe this wasn't a great directory as an example, because it only contains files that match star.pdb, but maybe you had 50 files that were PDB and 50 files that were text files, and you did not care if there was an FE in any of your text files. You only cared if it was in your PDB files. In that case, this command would be really nifty, because it's gonna filter for just the files that end with PDB, take that entire list and pass it off to grep to go searching for lines that contain FE. So just another way other than pipes to kind of combine things and get the output of one tool to get shunted into the output, as input to another tool. So pretty useful. It's worth talking about the limitations of these approaches. grep and find, grep in particular is really only meant for text files. If you have image data, if you have videos, if you have binary, you're going to run into lots of different file formats in data science. grep is really only useful for searching text files. The good news is FASTA is a text file, not whole sequence data. So a lot, even like VCFs and SAM files, you can still use grep on them, they're great. But once you turn it into a binary, once you compress it, if it's an image, grep is not gonna work. It's just not, it's not gonna be useful. So in that case, you may need to look around for some other utility to do searching. And Ryan had reminded me that we have a FASTA file somewhere, and there's a super useful use of grep that I use all the time. Well, let's find. Okay, so I couldn't remember where it was, which was good that we had just learned the find command. So now I'm like, oh, it's in the ag data folder. Great. So now we can cd to the ag data folder, and ta-da, there's our FASTA file. And FASTA files, let's look at the head of this. Sometimes they're huge, sometimes they're small. But if we look at the head, we can see the kind of general layout. There's a greater than sign, the name of a sequence, some other stuff, some comments. This is flexible, the format. This can be present, this can be absent, this can contain any sort of comments that the author of the file wanted, and then a bunch of sequence data. So the interesting question you can ask with grep is, how many sequences are in this file? Well, a really nifty regular expression way to figure that out is to count the number of lines that start with greater thans. If you count the number of lines that start with greater thans, you will know how many sequences there are in a FASTA file. So we're going to grep. We're actually going to count all the instances. So don't give me the lines back. I don't care about that. I only want a total count. How many lines in this file start with greater than? And the start with is one of those special characters in regular expression lingo that says, I want this character, but it has to be at the very beginning of the line. And we put our file name, and it tells us there are 5 sequences in this file. So if we get rid of the -c, it will give us the actual lines. But oftentimes, you know, there's tens of thousands or hundreds of thousands of sequences in your FASTA file. And it's super quick to just get the count with your grep-c and memorize this little regular expression. I use it all the time. Yeah, so there's one last exercise that you can go through. We still have about 20 minutes left. I think, you know, we've definitely gone through this really fast, and I've heard from a few people with one-on-one questions, but not too many. So, you know, if I hope you've gotten a lot out of this. If you need more explanation, I want to walk you through some options. Of course, this course has the documentation, and you can go back through it and you can watch the videos. I also want to acknowledge that a lot of this, all of the material today was taken from this really amazing organization called Software Carpentry. And it's a whole group of scientists who try to figure out how to make the command line the most easy to learn for scientists. And they maintain this as open source material. So you can go here, and this will be here forever, and it's completely open source. So you click on Our Lessons. And then we've been going through the Unix Shell. So you can actually learn other nifty skills. I like the programming with Python. I like the R for reproducible analysis. Both of those are great. We're going through the Unix Shell. If you click on the site, we have gone through introducing the shell, navigating files and directories, all the way down. We got through pipes and filters. So if you get through what we've done in this workshop and you want to do some more, you can do loops, shell scripts, and then we went ahead and did binding things. So we skipped 2 things in the middle. They're actually pretty nifty. We just didn't have enough time. But they're there, and you can go through them on your own. And you can always load up this CyVerse RStudio and go through the lessons. and it should work great because we're starting with the same data that they have in these lessons. There's also a sister organization called Data Carpentry. And here there are specific genomics lessons. This might take a little more setup. I'm pretty sure you could figure out how to do all of this in CyVerse, but it might be worth going through some of this. It starts out with the same Linux command line, get used to the command line, and then kind of goes through a bit more specific use of the command line for genomic data processing, which could be really useful. Yeah, and the videos will be there for you to use. So definitely lots of resources. And I personally don't mind if you email me if you have questions later on after this course. I'm definitely happy to help or happy to point you toward more resources online. The great thing about having computational things to learn is there's a lot of people who love the computer and the internet who have probably written a blog post or a tutorial or something else somewhere on the internet that you can get your hands on. And I can help point you to quality resources. Okay, with that, we've kind of conquered most of the material. We've got a few minutes. Does anybody want me to go through anything again? Do you have any questions?
So somebody asked in the chat about installing our libraries. We'll be going over that tomorrow. So this is just the shell today, and we'll do some R stuff tomorrow. To be a lot more like interactive and visual than just being in the shell.
Oh, another thing I was going to mention with software carpentry, if you want to do this again, or if you kind of want to see some of the other modules, they have a list of workshops, and I think you can see upcoming workshops and if they're any nearby, or you can even request for them to host a workshop at your institution. It does cost a little bit of money to get them to come. If you want them to come teach it to you, you usually pay for them to fly out and do that. I'm not sure how they're handling online, our new pandemic Zoom world. I don't know how much that costs, but it's worth mentioning. I've run a couple at UT. I think they've been pretty well received. I think it's a lot like this. I think it works a little better in person, but if you have 2 or 3 full days, you can go a little slower and actually do the exercises as a group. So consider that.
And just to follow up on what Meg said, I mean, outside of the fact that the Carpentries is just an absolutely amazing organization, and for anyone that enjoys teaching and sharing what you learn, become a helper, become a certified instructor. But I also want to add that one of the goals of the AG2PI are to run these workshop series, and we want to be as responsive as we possibly can to what your needs are. And we're trying to hit many parts of the spectrum, including bringing computation to a variety of life science researchers, and similarly life science to data scientists, engineers, computer scientists, and other things along those lines. So if you do have any ideas, or an area that you want to go in more depth, please feel free to reach out to Ryan or myself, and we're happy to work on trying to get one of those workshops together for you. And just to let you know, the AG2PI is going to run for 3 years at least. And so there's going to be a chance also to be doing these introductory workshops again in the future. So if you think that'd be helpful and you want a refresher or you want to share it with someone else, please just let us know. But there's a lot of great resources out there to bring this kind of education to a variety of researchers and life scientists in particular. And with stunned silence.
Yeah. So if anybody, if people have questions, feel free to unmute yourself or ask them in the chat. Also, don't feel like you have to, stick around until the hour. If just please give us some feedback on the independent feedback form that I posted in the chat. That really helps, especially since we will be running this again over the 3 years of AG2PI. Getting a little bit of feedback on what you liked, what you didn't like, things that we could improve will help me when I teach this again, probably a year from now.
So there's a question around how to use the find command, where why does find space dot space dash name blah, blah, blah will find files, but using the -r, the recursive option, does not. And this just comes down to some of the nuances of some of these older and original Unix, Linux commands. So the whole purpose of find is to start looking for stuff at some starting point with the idea that you're going to be descending into directories in order to find those files. So when it was designed, it was basically type in find and then type in your starting location. So that dot means start here where I am currently typing in this command. And so the -r recursion just doesn't make sense in that kind of context because it is descending into directories recursively to begin with. And I don't know, because I did have to pop in and out. When it comes to a lot of Linux commands, there's often really interesting / humorous / geeky history behind them. And so, for example, you guys got to see the command less. Did anyone ask the question of why it's called less? Meg is laughing, so you probably know the story, Meg. Would you want to share it?
No, you go for it.
Okay, so way back in the day, when these systems were first started, people were stuck on terminals that had like 25 lines, and so when you wanted to look inside of a file, you'd pretty much just go through it line by line. And then somebody invented this command cat, and so what cat does was just dump all the contents of a file straight onto your terminal, which was great. You could see everything that was in the file, but with only 25 lines. That you could see at once. If it was a big file, you just see the last 25 lines, everything else would scroll through. So then someone made this command called more. And more was an unbelievable innovation way back in the day, because what it let you do was page through a text file page by page based on the number of lines you could see. But more had this problem, which was it would only let you scroll forward. It wouldn't let you scroll backwards. So someone else said, well, I'm going to invent my own program that not only lets you look at it page by page, but lets you scroll forwards and backwards. And they called that program less. And the reason they called it less is because less is more. I wish I had there's a lot of bad puns in this. But of course, if you use more today, it has the backwards, and pretty much less and more are the same program. All these things have merged together. But cat is still good for just dumping file contents out quickly, because often we're looking at a small file like a config file, and going into a program like less and then quitting out of it is just extra keystrokes.
Yeah, just be careful what you cat. If you cat a huge file, you'll be waiting for a while. You might have to Control-C to kill it. Just check the file size first. Yeah. I'm glad you told that story. I had forgotten some of the salient details on more is less. That's all I remember is more is less, and I can never remember which is which, because they are essentially the same now.
Less is more.
And less is more, yeah.
And as you play at the command line and you read some of the documentation, you'll see some of these things referenced in there, sprinkled around. So some people out there do try to make not only the information immediately accessible in a very particular kind of format. It takes a little while to get used to reading man pages, but there's a little humor sometimes sprinkled in there. And when you write your programs, try to make them informative first, and then you can be punny later. Right, Ryan?
Yeah, absolutely. Don't name your grant a pun. Save that for the end of the proposal.
Yeah, thanks, Miranda, for that comment. I do think the exercises are really helpful. You know, we kind of debated about whether to take the time out of this workshop to do the exercises, and we decided that maybe just getting some content in was more important. So going back and doing the exercises, I think will really help cement the knowledge in your head and help you to make sure it's all sort of gelling in there. When I teach this to my class, they have graded homework, so they have no choice but to go to go practice, and it helps them. They usually struggle for a few weeks, but by the end of the semester, they're command line whizzes, so it's possible.
So if there are no questions, I mean, happy to wrap up. I know people are logging off. And the other thing too is Ryan was great at the end of last session, which is if people do want a little one-on-one time, please feel free to reach out to any of us, and we're happy to schedule a time. I'm actually just going to look at my calendar right now to see what the rest of my day looks like. But doesn't have to be this week. It can be easily next week. I would say just for this class, I'd even be willing to do it over the weekend if that's what works best for your schedules.
Nobody has any other questions, I'll stop the recording.